Hello, and welcome to this episode of Smart Talk, a data in motion leadership series. Today, we have a very exciting guest, Kishore Gopalakrishna. He's the CEO of StarTree. Kishore is no stranger to the technologist becoming a founder story. He is practically one. He started in technology, working at companies like Yahoo and LinkedIn, and then eventually founding his own company, StarTree. So, welcome, Kishore.
Thank you, Dinesh. Super excited to be on this show.
Wonderful, thank you. So, tell us a little bit about StarTree for users that do not know who StarTree is. It'd be fantastic given that StarTree has been like fairly young in the industry, but has been making some great waves as well.
Yeah, absolutely. So, for those of you who are not familiar with StarTree, so this is a cloud-based real-time analytics platform, and this is built on around Apache Pinot, which is like the open source project that we started back at LinkedIn in 2014, 2015 timeframe. And one of the key things that differentiates us from other analytical providers is we focus explicitly on speed at scale. And also we cater to the companies that want to provide analytics to their customers and partners. So we kind of refer to that as user-facing analytics or external-facing analytics. So there are key requirements there in terms of latency, concurrency, and even freshness of the data. So those things make it really, really challenging for companies to address the needs of user-facing analytics, and we specialize in that. And that's one of the key differentiators for StarTree.
Data freshness, a topic really, really close to my heart. But I'm also, very excited about this open source foundation that you have on it, right? So Apache Pinot is what it's based on. I would like to know a little bit more about Apache Pinot, like, why Apache Pinot? Why did you found this, like, way back in 2014, 15 timeframe? What was the need that, made this wanting to build Apache Pinot?
Yeah, absolutely. I mean, one, I'd already built another database before Apache Pinot. This was Espresso, which is like MongoDB and other Cassandra and other systems. It's like the one that stores pretty much all the LinkedIn data. And for me, after that, I knew how hard it was to build a database, and I really didn't want to build one. So it was really a bunch of things that happened together, which forced us to build another database. And I think the first thing was really about LinkedIn thinking about how can we bring analytics to the masses, right? When I say masses, it's like beyond LinkedIn, like all the hundreds of millions of members of LinkedIn, how can we serve analytics to them? That was a pretty cool idea from a business point of view because they wanted to improve the engagement on LinkedIn website. And that forced us to build. And the first version, we didn't actually build Pinot. First version was launched on something similar to Lucene and a search system that we had already built at LinkedIn. And the product was very successful, but behind the scenes, it was very expensive for us. We needed almost, I tell the story multiple times. It's 1,000 nodes to actually run Who Viewed My Profile, which pretty much every person on LinkedIn uses it now. So that was huge. And I think that is when we saw the power of building something like this, building data products, providing insights to our users. But at the same time, we found that the backend was not something that we could maintain or operate. And last but not the least, it's super expensive. And that forced us to rethink and say, like, hey, there is no one who has attacked the scale at where that is needed for external facing analytics. So it's kind of on one hand, it has the workload of an OLTP system, which has these millions of queries coming in per second. On the other hand, it has the functionality of an analytical system, which is OLAP, and which is slicing and dicing and aggregation. So there's getting the best of two worlds into one system. That was a challenging thing, and no other system solved it. And we knew the power of what it would enable us to do at LinkedIn when we have a system like that. And that's what set us to build Apache Pinot. And that changed the game, right? I mean, today, if you look at any number on LinkedIn or Uber or Stripe, they're all actually coming from some Apache Pinot backend. So it's people don't believe this, but they're almost serving 200,000 queries per second just on LinkedIn. So
Wow.
it's a massive success for us in terms of just from that going from ideation to actually building a system for scale and seeing the adoption in a lot of different companies.
Fantastic. And how big is the Apache Pinot community today?
I think overall across looking at the Slack community and the Meetup community, we are close to 10,000 members across both.
Very cool. Very cool.
Yeah, it's amazing to see the growth. I remember when we started, we had like 100 members in the Slack community, and then seeing that growth go from like 100 members to really massive adoption of Pinot, and also the growth in the community. It's fantastic to witness that.
Yeah, I mean, that's one thing that I've seen from the open source communities as well, where if the project is good, it's convincing, if it's exciting, the crowds will come, they definitely want to be part of that movement. So that's fantastic. So switching gears into the topic of the day, we decided we'll be talking about observability for whatever reason, but I believe now I can clearly see why we picked that particular topic, because you spoke about user-facing analytics and real-time analytics, which is the heart of what you do. And data in motion is kind of like heart of this talk series. That's what I've been like, working with like so many different data leaders. So it makes perfect sense for us to connect today. However, I've said this many times before. Data in motion is kind of all different types of like streams: log streams, click streams, social streams, event streams, where all types of different streams coming from IoT devices and whatnot. And so when you talk about log streams and event streams from across the IT infrastructure, it is kind of almost inevitable that observability is that elephant in the room that we need to address. We need to talk about that. So I think it'll be a great topic if we can talk about the relationship between real-time data and observability. Um, First off, let me open it up by asking a very generic question. What is your take on observability? Like from your vantage point, how are you looking at observability?
I mean, I have been in the data space for a long time, and it's amazing to see actually the definition of observability change over time. Right? I think that is something that is interesting to see, because earlier it used to be just like things like Splunk and what they do on the logs. I think that was then observability, and then we also got into metrics, and then companies like AppDynamics, Neural Lake, all made metrics as the first class, and then slowly now we are getting into traces as well. And now is like even people just monitoring the click stream and then looking at the funnel analytics, user analytics, and user behavior. They also consider that as observability. And last but not the least, even monitoring the business metrics of like, hey, I have this revenue, I have this derived metrics on top of that. And that's also, so I think the definition of observability itself is very broad. To me, I think it is metrics, logs, and traces, monitoring of those. But the new thing that is getting added into that is the events. So some people call them as MELT, metrics, events, logs, and traces. Some of them just refer to metrics, logs, and traces as. But in essence, to me, in short, everything is an event. Whether you have a log in that, or a metric in that, or a trace in that, it's just a specialization of that. To me, if I take a step back and then look at it, it's pretty much having insights over events, right? And if you can get insights over all the events that you're capturing, that's basically observability to some extent.
I completely agree. And you're right when it comes to like, the definition having changed over time. I have personally seen, and I've worked in the observability space for quite a bit as well. And I've personally seen companies that were originally like infrastructure monitoring alone, or, network monitoring alone, suddenly start adding on additional capabilities and then calling themselves, more of an observability platform and all that as well. One thing I do see value in that is the connectivity across all these different monitoring needs. If you monitor infrastructure, you also want to understand what went wrong as a result of that particular cluster failing or so forth, which means now you're like trying to understand, failures or root cause analysis on the network failures as well. And then potentially like connecting that with like, other infrastructure components, and also maybe even the application needs, application failures as well. If you consider that, there are quite a lot of vendors. It's a crowded space, by the way. There are quite a lot of vendors there talking about full stack observability, unified observability, and the whole nature of everything being together and all that. But I know that you have a slightly different perspective on it. You call it disaggregation or so forth, right? So why don't I give you the mic and like you kind of explain your perspective on this particular stack today, and what is your take on it?
Yeah, no, I think that's a great segue into what we wanted to talk about in this. Is really how the observability stack is evolving over a period of time, right? I think if we go back a few decades ago, right? And there is always concept of all-in-one, right? I mean, even if you look at starting from Oracle, which was like pretty much the only database a company needed at some point, right? You would get your events in it, you would get your sales order in it, you can pretty much do everything as part of that. And then slowly, as the scale increased, we could see that that one system is not good enough to do all the different things that happen within a database, right? Or even within that particular stack. And that's the same thing that we are seeing in observability, right? And if you look at, this has already happened in analytics stack. So this is not new phenomena that we are seeing. It's just that it's now transferring into the observability stack as well. Like if you look at Databricks, for example, the query engine and the data is actually separated. The collection is separate. Like you have Kafka, Red Panda, and things like that. And then even the emission is like agents, right? So there is this, all these things are getting broken into different layers. And now if you look at observability stack as well, what is happening there is, if you look at let's say um, Datadog or App Dynamics and New Relic, and if you deep dive into the technology stack that they have internally, they have a collection, an agent layer first, right, which is basically emitting all the different events from your Kubernetes or from your services. And that used to be a huge thing because it was very hard to actually get this data. And that is where it was a big moat that App Dynamics and New Relic all these had. But that has become standardized now, right? So now most of them use either Prometheus or Open Telemetry format, and the formats are getting standardized, the agents are getting standardized, and it's almost become a commodity. So now you can get to the next layer, which is, what was the collection layer? And people had to build their own, right? When before Kafka and messaging systems existed, people had their own way of collecting this, and they would use some sort of a collection service. Now that layer is also getting standardized, and if you take a peek at like all the technology stacks at these companies, they probably use something like either Kafka or Red Panda or Kinesis and things and systems like that.
Yep.
So you kind of have agents, now you standardized on the collection. And then there is also processing layer that is also getting standardized, right? You had Flink, Samza, and there are a lot of other systems out there that are actually doing stream processing, which kind of transforms the data or like add some additional things, which is not necessarily needed in the observability stack, but it is an optional thing that some people do have that additional stack as well. But then they put the output of that back into the stream source, which is like Kafka. And so now that is another layer that is common. And then goes into the storage and query layer, right? So and then most companies ended up building their own storage layer and the query layer as well, but they kept it very specific for solving the metric use case, the logs use case, and the traces use case that is coming in. But if you look at each one use case, there are different indexing techniques that you actually apply. For text, it's a different indexing. For metrics, it's a different indexing. And then you have the visualization layer. To kind of sum it up, what is happening right now is that this is getting standardized. This stack is getting standardized. Doesn't matter who the vendor is, whatever they're doing end to end, they always separate out these things in within their stack. And that is where we see that the opportunity is that these, instead of having single vendor doing an all-in-one solution, the horizontal standardization is happening, and there are multiple benefits. And this is not happening just because you can do it, but I think there are other advantages. One is, people are realizing that the data that they use for metrics, they can actually do more things on that data, not just about monitoring and looking at visualizing it in Grafana. They can actually build models on that. They can do anomaly detection on that. They can do alerting on that. So there are a lot of other data scientists can actually use that metric, and you can run Spark jobs, reports, and things like that.
Send it to sim systems, you can do a whole lot.
Yep. Exactly, right? So you can even get into security and things like that. So I think the number of applications that you can build on the same data is increasing a lot, right? So you can actually use the data for other applications. So what that means now is, but if you go with a single vendor, now you don't have access to the data because they are only giving you one kind of visualization, and that opens up. So that's, people are realizing the benefit of, hey, this data is not necessarily one application. I can actually run multiple applications on top of it. And the fact that now if they come up with new applications, they can actually just build on the existing stack. So I think I give this analogy in other places as well, is we kind of, if you look at when you go and try to buy a toy for your kid, you have two options. You can just buy a toy that is ready made and it's a robot. It basically does XYZ, or you can buy a Lego set. And the thing is, like with the Lego set, you can now build so many different toys, and there is a very well established contract between every Lego piece. You can join them together. You can build so many things. Obviously, it is a do-it-yourself model versus a toy that is like, you, as soon as you get it home, you can actually do something with that toy. So I think it's the whole data ecosystem is basically getting transformed into like a list of composable systems, and it is something that is happening in analytics area, and now we see that happening in the observability side as well.
Very cool. Very cool. But on that note, though, if I were to ask you purely from experience, in my conversations with like CIOs and CTOs in companies that have been like trying to dabble with like observability platforms, one of the common things that I hear is, hey, I have 5 different departments, one for like cloud infrastructure, one for like applications, and one for DevOps and whatnot. And everybody has their own set of like monitoring tools, so dozen tools here, dozen tools there, dozen tools there. So I lack the single pane of glass, inability to look inside like all of this and understand what's going on across my enterprise. Why is it a particular failure happening, like a website down or something like that. So troubleshooting becomes like a major challenge when I have like a plethora of tools. The second thing that I have is like the cost. Obviously I have like 30, 40 tools across the enterprise for monitoring. So the cost is like humongous. So to your point about this Lego model based of like putting things together, yes, it's DIY, but I feel like you're saying it gives you more flexibility, gives you more like an ability to like put it yourself together and all that. Do you still feel that this model will still yield um, a lesser cost model for the CIO or the CTO? Will also be able to like eliminate these dozens of tools and be able to like standardize on something more sophisticated that gives this CIO or the CTO the flexibility to say, I have a single pane of glass. Do you feel that way?
No, absolutely. In fact, this is the reason why they have so many different tools. Again, the tools will continue to exist. I think what the tool does will actually change. They will focus on what they're supposed to do and do it really, really well. Because what is happening today is, if you look at that single pane of glass, there is no way you can actually have that unless you capture the entire data of the company, right? And the data right now is spread in like so many different systems. It's impossible for you to capture that. And I think the disaggregation will actually help in someone coming up with like a single pane of glass, and that can actually interact with all these different systems, right? And the disaggregation, the best part that it actually enforces is the contract between the two layers, right? So I end up having right APIs. Like look at S3, for example, right? There was no a standard API for looking at blob storage. But S3 became popular, and that established as like the de facto, even though there is other APIs, but S3 is the one that ended up becoming the standard one, right? So whoever is the most prominent in that space ends up becoming like a de facto API. Now we have the Prometheus or the hotel format in terms of how you actually send this metric. So that's another standardization. And once the API gets standardized, now you can have different systems, and it actually makes it very easy for the CIO to actually replace the underlying system as long as they adhere to this standard format. And to me, having that allows someone to come in and build a fantastic tool on top of these platforms that can actually look at, hey, now you have this data in this system. Is that talking SQL? Yes, I can then talk to that. Is it talking PromQL? Is it talking LogQL? Is it talking TraceQL? I can actually pull all these things together, and I can provide a fantastic tool, and that which is it's almost impossible to do today. And that's the reason why a CIO has like so many tools, right? Because each tool can just work on the data that it has. They are not focusing on the interoperability or like the federation concept, and that's going to change, right? And if the tools start thinking about, I can actually build a pretty cool tool and a very efficient and a very promising tool by leveraging data across multiple systems and accept the fact that the tool doesn't own the data, but it's actually accessing data across different sources. And that's the right way to solve this. There is no way. I mean, I've solved. I've also built a system like Third Eye, which is an anomaly detection and root cause analysis. Um, and I've sat through how the SREs, the operators actually debug and do the triaging. You are absolutely right. They go through like so many different tools, and the reason is not because it's a tool problem. It's just because the data is spread in like so many different ways, and each tool is coming with its own data. But if you kind of separate the data from the tool's functionality, the tool can potentially do more things than what it's doing today.
So in a way, you're saying right now with this uh, proliferation of tools across enterprise, there are data silos that inadvertently happen,
Yep.
and you are liberating that by saying, pull all the data together. Now you have like one single pane of glass at the data level, at least, where now you can use all kinds of querying and API mechanisms to access that and use any kind of visualization from the flexibility and interoperability perspective. So in a way, you're like
Yes and
democratizing
no. Yes and
observability.
no. I think it's you're trying to minimize. I think in at the end of the day, if I look at it from a company point of view, you want to minimize the number of tools, right? It doesn't mean that you will just have one tool in every layer, right? I think one system in every layer. So you want to minimize. So we are saying yes, we will come up with like one system for metrics, logs, and traces in terms of storage and query capability because they're all converging in terms of the requirements of what needs to happen there. But there are other systems as well. Like if you try to do a root cause analysis, for example, you probably want to look into what are the campaigns that are launched, what are the holidays that are there. Those things doesn't have to be in this system. They can be coming from an API. They can be coming from your Jira system. So you might want the tool that is built on top to have these contracts with other systems as well that they can actually pull the events from. So there
Right.
will be more than just the metrics, logs, and traces. Absolutely. I think that's a given. It's never going to be one system. I think every company tries that they will come up with one system that solves everything else, and then they just end up having N+1 system. So
Very cool. A fantastic perspective. Thank you so much for sharing that. From a guidance perspective, real quick, if you can, offer any kind of guidance for like data teams that are working on their data architectures to modify to accommodate models like what you're suggesting, right? What would they have to do?
I think I always suggest this from the systems perspective. Like just first understand the systems, all the systems that they have, and ask why that system exists. Right. I think most people just go to the next cool thing and then think that that will solve all the problems, but they don't really think about why was this system put in place and what problem it is solving. And second, how is it solving? Most people ignore that. Right. I think I just without I saw someone actually moving from Elasticsearch to Snowflake, and then they realized that okay, Snowflake doesn't have text index, right? So it's just you don't make changes like that because that another system is a lot more popular than the other system. But try to understand from first principles, why was the existing system is there, why did the existing system, what was it solving, what hard problems was it actually solving as well, and then figure out. I think as you rightly mentioned, you can go all the way to the extreme and say like, okay, can we bring in one system that solves all of them? But it's generally very hard. So I think you once you understand the problem, you will be in a better position to minimize the number of systems that you need, right? And always think about like 4 or 5 years from now in terms of what new applications that you will be building, and the system that you are actually bringing in, can it scale to the new needs, and also can it how solid the design is of that system, that it can actually adapt as new things happen within the ecosystem. I think those are some of the attributes that I would keep in mind when you're picking up new system or even trying to re-architect.
Thank you. Thank you. Um, any quick case studies that you can think of, where um, you have seen this kind of success with this kind of a disaggregated stack that you're talking about?
Yeah, absolutely. I think I would like to bring in like the Cisco use case that I think they also presented in one of the real-time analytics summit that we had. And there is also a very nice blog. So they took this Elasticsearch and Kibana and the Beats and Logstash and that stack, and they actually had they repurposed with Apache Pinot as the storage engine, and then they built a Grafana plugin on top of it, which mimics the Kibana like interface on top of it. So they were able to put together the stack end to end with, and this is for the entire WebEx monitoring. So we are having this call on Zoom. So think about like having monitoring on all the calls that are happening. Right? I think that's something that they did with WebEx, and they had this exact disaggregated stack that we mentioned with Kafka in between, with agents sending out the data, and then Pinot is consuming it, and then Grafana on the other end for the visualization.
Fantastic. Fantastic. So last thing, Kishore, this has been a great conversation. I would like to close out with your outlook on the next 2 to 3 years about this particular space. You have a very unique vantage point, obviously, as the CEO of a company that is hot and happening with like user-facing analytics, and then now you're talking about this emerging into spaces like observability. Would love to understand how you're seeing the next 2 to 3 years emerge.
I think the one thing that I am excited, obviously, apart from there is going to be massive improvement in the cost efficiency and the speed of querying this data. I think that's something that's going to happen. The blob stores are becoming much more powerful than what it is. So you will see that. But I think what I'm excited about is what kind of applications will get built, given now that you can actually do get this kind of speed, right? I think that's always the way evolutions happen in my view, right? I mean, you kind of go from walking to cycling to car to aeroplane to rockets. I think it's all, in the end, they're all solving the speed problem. But once you get that speed, you can actually solve a lot of other applications. I think that's where I feel the AI stuff is also going to be a massive change in terms of this data, because this data is actually super powerful. And I would say the amount of data that we are capturing today is massive, but probably most companies are extracting like 1 to 2% of the value. Most of them, they're just leaving it on the table. I mean, that's the whole pitch about real-time analytics for us is like the data value becomes zero so quickly. And if you don't act on it, you're most likely going to lose it. And you have a very short window to actually capitalize on that. And the observability is really the essence of that is data in motion and real time. I think that's those two things have to come together.
Fantastic.
And AI is going to change the game there as well.
There you go. We had to have AI in the conversation for sure.
Yes, absolutely. Yeah.
Kishore, thank you so much for a wonderful conversation. This has been really, really good. I think the forefront facing perspectives that you have about like what AI and observability and data in motion coming together, I think the possibilities are endless. So thank you so much. Appreciate it. And have a wonderful day.
Thank you, Dinesh. Thank you for having me on the show. It was a pleasure.